Hello Finxters and welcome to a new Pandas tutorial. In this tutorial we will learn about the Pandas cut function. And this function bins values into separate intervals and it is mainly used to analyze scalar data. And we will start with an introductory example. First of all, we import the Pandas library. Then we create a Pandas data frame with two columns, a diver column with string values and a score column with integer values. And yeah, the outputted data frame now shows a data set with 6 different divers and their respective score that they achieved. And now we apply the Pandas cut function, and it just looks like this: pd.cut. And now there are two mandatory parameters that we have to apply. The first one is x, and I will explain that in a minute. And the second one is bins, like that. So this is the outputs, and yeah, as I said, there are two mandatory parameters. The first one is x, which expects a list that we want to bin. In this example, we apply the score column of the data frame. And the second necessary parameter is bins, and this one expects the number of bins as integer value or a list of integer values. And in this example, we assign the number 3 to the bins parameter to state that we want to create 3 equal-sized intervals. And yeah, the output shows the interval for each score. For example, Alice's score is 6, and it is assigned the interval parentheses 4.0, 7.0, and then square brackets closed, because 6 lies within this range. Yeah, but how are these intervals calculated? Well, by assigning the bins parameter the value 3, we state that we want to create 3 equal-sized intervals, and the intervals are just calculated like that. We take the maximum value of the score, which is 10, of the score column, which is 10, and the minimum value, which is 1, and we subtract these values from each other. So 10 minus 1 is 9, and we divide 9 by 3 because we want to create 3 intervals. So, and 9 divided by 3 is 3, so 3 is the size of an interval. And if we have a look at the interval that I just mentioned, 4.0 and 7.0, we see that 7 minus 4 is 3, so the interval size is indeed 3. So if we have a look at the lowest interval, it doesn't start with 1, but with 0.991. And yeah, why is that the case? That's because of the meaning of the brackets in the intervals. The intervals here are half-open intervals. So the interval 0.991, 4.0 means that the values included are greater than 0.991 because of the parentheses, and less than or equal to 4.0 because of the square bracket. And yeah, so the lowest value has to be a little bit smaller than 1 so the 1 is included in that interval. And so we can make this a bit better visible now by creating a new column for the data frame which contains the intervals, and we do it like this. The new column is named interval, and this is equal to the cut function that we just created before. With 3 bins again. And as we can see, now the each interval is assigned to each score, so it's a bit better visible what interval belongs to which score. So in this example, we applied the cut function using 3 intervals by assigning the bins parameter the value 3. But now we want to assign the bins parameter another value, for example 5. And again, putting that into this data frame to make it better visible. And actually we can just copy that and paste it, and we just change the bins parameter and assign it the value 5. And the new data frame looks like this. We now have a little bit different intervals. These are now 5 equal size intervals, and the length of each interval is calculated in the same way as before. We have the maximum value, which is again 10, minus the minimum value, which is 1, and 10 minus 1 is 9, and we divide that by 5. So 9 divided by 5 is 1.8, and so each interval has the length of 1.8. Again, except for the smallest one, it again starts with 0.991. And yeah, apart from an integer value, we can also assign the bins parameter a list of scalar values. And this way we determine the interval boundaries directly. And this is how we do it. Again, we change the interval column. And this time we assign the bins parameter a list. So the list that we assign the bins parameter creates 5 intervals, as we can see in the data frame. And if we do it this way, we specify how many intervals we want to get and also how long each interval should be. And in this example, we created intervals that all have the same length, but that doesn't have to be the case. We can do lengths that are not, we can create intervals that are not equal size. We could, for example, change the intervals to this. And that way we get intervals that are not equal size. So as we can see, the interval from 0 to 4 is like 4, it's a range of 4, and another interval is from 5 to 6, and it is just a range of 1. And so these intervals do not have to have the same length, or they can be whatever we define that. And we can also, or we might define intervals that where some values from the data frame do not lie in any of the determined intervals. For example, like this. And that way, as we can see, the scores 8 and 10 do not lie within any given interval, and Pandas handles these cases by assigning these values the interval nan. And when that happens, we know that our intervals that we created do not cover the whole field. The intervals that we've seen by now are all structured like this, with the parentheses opening the interval and the square brackets closing it. And that way the rightmost edge is included in the interval. And that's because the cut function provides us with the right parameter, which is by default set to true, so that way the rightmost edge is included in the interval. Or we can change that parameter, of course. And this is how we do it. Again, we change the interval column. Again, we create 3 equal-sized intervals, but now we set right to false. And if we do that, the interval structure has now changed, and this way the leftmost edge is now included in the interval and not the rightmost. Thus, the smallest interval now starts with 1.0, whereas before it started with 0.991, and now the biggest interval ends with 10.009, so it's a little bit bigger, so the value 10 is included in this interval. We can also label our intervals to give them certain names and categorize them. In this case, categorize each score that we have. Therefore, again, we apply the cut function. Again, we create, for this purpose, 3 equal-sized intervals, but now we apply the labels parameter, which expects a list of how we want to basically call each interval. For this purpose, the smallest interval is called bad, and the medium one is called good, and the biggest one is called exceptional. And as we can see, if we apply that, now each interval has a label, bad, good, and or exceptional. So we basically categorize each score and evaluate it. And this is very useful if we don't want to have like the numbers where the score is included, in which interval, but we want to like label each interval to evaluate the score. Let's have a look at another example here, where we create the following intervals. We create the following bins. And if we create these intervals using the scores, we can see that Dave's score, which is 1, is not included in any interval, although we started at 1, started the lowest interval basically at 1. And that's because the right parameter, which we've seen before, is by default set to true because we didn't change it here. And that doesn't include the leftmost edge, which is 1. And thus the score 1 is not included in any interval here. And so what do we do to include the score 1 in the interval while not changing the right parameter, because we want to keep the interval structure with the rightmost edge remaining included in the intervals? And we can achieve that by applying the include lowest parameter. And this is how we do it. We just set the include lowest parameter to true, because by default it is set to false. And yeah, we just set it to true to include the lowest value. And if we execute that, we can see that now the score or the value 1 is included in an interval, unlike before, because we included the lowest value. And again, the interval starts at a lower value than 1, because that way 1 is actually included in that interval. So yeah, that was the cut function. The cut function provides us with lots of possibilities. We can create various intervals, we can change the intervals structures, and we can label the intervals to categorize our data. And that was the tutorial. I hope you liked it. I hope you learned something, and I see you in the next one.